Hello everyone, I'm Anil Batra. Today I will present a work with title Predicting Implicit Arguments in Procedural Video Instructions. This work is done with my collaborators Laura, Marcus, and Frank. First, understand what is a procedure. As per the formal definition, it defines how we perform actions step by step to complete a goal-oriented task. Learning by watching procedural videos and performing the sequence of steps in a procedure builds our memory to perform the similar things unconsciously in future. The focus of current work is procedural instructions. We need to see what the significant attributes of procedural instructions with some examples, such as using deco blocks to make stretchers, making a cake, following a cooking recipe. Procedures are structured with clear progression of actions to perform a goal-oriented task. And actions in this procedure sequence depends upon the previous instructions or context, which allows humans to make contextual inferences, build long-term memory, and common sense knowledge. Now we look at why we study procedures or procedural instructions. Building AI machines to understand the procedures will help them all. It will help to make personalized systems or chefs to alter the instructions or ingredients for allergy conditions in a cooking recipe. It allows AI system to understand the unstated information. For example, dressing and bread are added to a bowl with cucumbers and lettuce in step 5. It also helps the system to build memory by tracking unstated or implicit mentioned entities in a given instruction. Furthermore, parsing procedural instruction is a crucial step to convert the natural text into semantic roles for robotic applications. For example, the instruction chop the tomato and bread with a knife is parsed into semantic role with verb and its semantic arguments. Learning about implicit entities will provide granular details about entities for robot to perform actions. Now we look at specific example of procedural video in a cooking domain. The images on the left are visual depictions of actions and the corresponding text is shown on right. Consider the step 2. This is anaphoric instruction, that is the word it is pronominal reference to oiled pita bread. We infer such information from the linguistic context given in the previous instruction. Similarly, step 3 and step 4 mentions bowl. Here, linguistic context is insufficient to differentiate the two different bowls, and we need visual context to resolve the ambiguity. Lastly, the step 5 and step 6 are elliptical and requires to make both linguistic and visual context to understand that the dressing is a mixture from step 3, bread is an oiled pita from step 2. These two different mixtures are added to vegetable mixtures from step 4, such which is implicit from multimodal context. We want to develop systems which can understand such multi-step and elliptical instructions, infer and track implicit and explicit entities from multimodal and temporal context. In this work, we focus on multimodal model such as GPT-4o and Quen2-VA. To test the current ability of models, we develop a simple annotation scheme. That is, we first identify all the implicit entities or unstated mentions in a cooking recipe. Later, we convert them multi-step instructions. Later, we convert these multi-step instructions into simpler semantic roles. Now let's understand the annotation scheme step by step. In the first stage, we ask the human annotators to resolve the anaphoric information and add missing information for elliptical instructions, such as it is converted into olive oil and pita bread. In step 5, dressing and bread is replaced with involved entities for the mixtures and where these entities are added to. Similar for step 6. In stage 2, we ask the GPT-4o to convert these multi-step instructions with implicit information into simple instructions considering only single verb and its corresponding semantic arguments. In the current work, we focus only on what and where arguments. Finally, the human annotator refines the noisy predictions from GPT-4o and creates our new benchmark. We name the benchmark as implicit with SRL, that is, multimodal cooking procedures videos with implicit information structured in semantic role label framework. More information about the dataset statistics and annotation scheme is available in our paper. We use the proposed dataset to test the ability of current models to infer implicit information and track entities from multimodal context. Specifically, we utilize the closed task probing, that is, we mask the entities for semantic arguments and pass it to the model for prediction. We tested the task in multimodal and single modality scenarios. We also fine-tune Quen2VL model to improve the performance. However, we do not have specific training dataset. Towards this, we follow similar technique in the prior works. We follow the similar techniques as in the prior works, that is, generate silver standard dataset using GPT-4o and fine-tune multimodal LLM using low-rank adaptation. We design a chain of thought prompting with in-context examples from human annotated dataset, that is implicit with SRL, and pass it to the GPT-4o model. We use training dataset from the tasty data. The silver standard dataset is parsed into the format similar to implicit with SRL. Later on, we fine-tune Quen2VL model with next step anticipation tasks and semantic roles. We compare the diverse models and our fine-tuned model on closed task probing. We use F1 score for entity argument prediction. To further understand the ability to predict implicit information, we compute F1 score only for implicit entities, which are not mentioned in the current procedural instruction, and requires model to perform multimodal and temporal context. The current plot focus on three models. In text-only setting, smaller Quen2VL model has very poor performance, has poor F1 score for implicit argument prediction. However, fine-tuned version has better performance than GPT-4o. Similar trend follows for video-only and multimodal settings. Overall, we observe that multimodal context is more helpful to predict the implicit and explicit entities. We also study the effect of argument prediction across semantic frame position in multimodal procedural inputs. For two models, GPT-4o and our ISRL Quen2VL model. The current plot shows only for implicit what argument prediction, and additional plots are given in the paper. It shows that both GPT-4o and R's model achieve strong results at early semantic positions, but performance decreases gradually as the semantic position increases. It is interesting that R's model achieves better performance for implicit argument prediction in comparison to GPT-4o. In conclusion, our new dataset helps to develop models to interpret elliptical instructions and infer implicit information from multimodal context. We also show that smaller models fine-tuned with silver standard dataset can achieve performance close to larger models such as GPT-4o. Lastly, our analysis show that current models still have difficulty tracking implicit entities, hence our dataset is an initial step to develop improved models in future. More information about code and dataset is available on our project page. Additional qualitative examples are also available. Thank you.